Hello everyone, we're going to start learning today about solving quadratics by factoring. So we've started looking at some of the strategies last class, but let's take a look at everything that we have to learn today. So we'll be learning about factoring using the square root property, which is part 1. In part 2, we'll be learning about how to solve with factoring. So a lot of factoring examples here. And then finally, we're going to learn about how to move between all three forms. We still have a little bit left to learn after this, but we have a pretty good idea of how to write an equation of a quadratic from just the graph alone. So let's take a look at the schedule for the next 2 days. So today, we're going to finish this video, and you're going to fill in the odds with me. And then you're going to be working on the evens. For homework, you have a little bit of time to do that. And then the sub is going to pass out a worksheet called the 11.4 part 2 worksheet, in which you'll be working on the evens. Okay, so all you need to worry about for today, your responsibility, are the evens of the 2 pages that you'll be given. Okay, so it's the evens from the guided notes and the evens from this part 2 worksheet that you'll be doing. That's about maybe 6 or 7 problems, maybe 8 on the worksheet, and the guided notes has a few more. But you'll be given class time to do that. And the only other thing we'll be working on today is the ALEX, as 10 topics are due on today, on Friday, as well as trying to reach getting close to 20% on your pi. Okay, and due already today was part 1 of the worksheet, which I already gave to you. Okay, we will grade that later. Okay, and then looking forward into next week, we will do a lot of homework checks. We'll probably end up just providing you with the key and keys, because there's going to be multiple things to look at. There's at least 3. And then we'll take a look at the odds from the worksheet down here that you started, that you'll receive today. And then we'll move on to a new set of notes, and then we'll assign the last worksheet from 11.4. Okay. So at this time, make sure the sub is passed out all of the guided notes to you that look like this. And it is a 2-page packet, and we're gonna go ahead and get moving on that. All right, so what is solving by square roots, and what does it accomplish? Well, we're just trying to get x alone, and one way to do that is with the square root. Now you'll notice all of these quadratics down here, they are missing a term that has like bx, right? Remember ax squared plus bx plus c? None of them have a linear term. And when that happens, you can use square roots. Okay. So we use this thing called the square root property, and it's actually pretty simple. So like if x squared equals 64, then x is plus or minus the square root of 64, which is 8. So it's just a way to go from x squared down to x, okay? And so the main steps for this is to isolate the squared term. Normally that's x squared. It could be something like this squared. Isolate that, square root both sides, adding the plus or minus, and then just simplify the square root and solve for x. Okay, so I've done some examples over here for you. Feel free to look at those on your time. Let's just take a look at the odd problems together. So first I would add 4. So the square root property tells us that I can square root both sides once this is isolated. Therefore my answer is just plus or minus 3. Because 9 is a perfect square, it equals 3 times 3. Okay. Sometimes you'll have to divide to isolate x squared. Okay. We can take a square root here. And when you take a square root of a fraction, you are allowed to take the square root of the top over the square root of the bottom, like that. But we know by fractions that we can simplify that, reduce that to 1/4. Okay. So kind of combining those two things together, I'm going to isolate by doing these steps. Okay. And I'm going to use the square root property since x squared's alone. Okay, and 3 is not a perfect square, so we're kind of stuck here. We would want to see if we could simplify the square root at all, but we can't. So we would stop here. Okay. So here we go, we have this, and this is going to be equal to 8, because 63 minus 55. And then we'll take a square root. Now, when we simplify square roots, we're on the hunt for finding perfect squares as factors. And 8 has 4 as a factor, which is on my list up here, my running list, and perfect squares at the top. So the way this will look is the 4 will come out, and the other 2 will be left under there. And that will be my answer. Okay. Here we get a glance at something a little bit different. It's a squared quantity, but still you can apply the square root property like this, and then move the 1 over. You're always going to put that number in front of the plus or minus, and the square root of 36 is just 6. Now we can do better than this. We can actually split into 2, because the hope is that by doing that we can actually get just whole numbers as answers, and those are the answers. You can confirm that, like put a 7 in here. 7 minus 1 is 6. Squared is 36, right? Okay. And if at any point I've gone too fast, you can go ahead and pause right now. Here are the answers so far. Okay, we just have one more. We want to isolate the squared piece. Okay, then we're prepared to take a square root of both sides. So like when you do that, you put the plus or minus there. And then when I move this 10 over, I'm going to put him in front. And then square root of 2, I can't reduce that at all, simplify that at all. So that would be my answer here. So this is a review of kind of what you had done to prepare for today. Okay, something a little bit new/different is solving square roots by factoring, but we've already done factoring, so it's just you got to learn the other details. And one of those details is the zero product rule, which says that if something times something is 0, then one of those two things is 0. Because the only way you can make 0 by multiplying is if one of those things was 0, right? The only way to make 0 is if one of the two things you're multiplying is 0. And then we're using that fact to help us solve for x. So the steps here are to set it equal to 0 in standard form, okay? Factor, Okay, normally that's going to be with that puzzle and the factor by grouping. But you might spot a GCF that can be taken out, which is normally x. We'll see some problems with that. And then sometimes some solved by square root problems can sneak in here if there's no middle term. Okay, and then we'll use that zero product rule, and then we will solve both. So this is best explained with an example. So I'll kind of line up the steps for you. Step 1 is to set it equal to 0. So that would be this step. The factoring part is all of this and all of this. Okay, stuff that you're used to, doing the factor by grouping, pulling out, separating into two groups, pulling out the GCFs, and then pulling out the binomial. Okay, that's step 2. Step 3 is the zero product rule step, where you set this equal to 0 and set this equal to 0. And then step 4 is actually doing out the equations. Normally they're very simple 2-step equations to solve for x. So I'll go ahead and continue with the odds. So you have to set it equal to 0 first. And then remember, this is of the form ax squared plus bx plus c equals 0. Every problem will be. So a is 1, b is 6, and c is negative 16. So a times c is 1 times negative 16. Okay, and filling in the puzzle, those are my answers. So I can go in and do that. Okay, and you remember at this step, you're always going to be pulling out an x. Sometimes you can pull out a number as well, but always expect to pull out an x there. Okay, and then you can say, oh, let me show you. Both of these have this term, right? Now, you can take that out front. And take it out front for that one as well, leaving you with just this. And that completes step 2, the factoring step. And then you say, hey, in order for those two things multiplied to be 0, either the first one was 0 or the second one was 0. And then you just do a quick solve, and then you're all finished. Okay. Let's do one more of those. So 3x squared minus 4x minus 7 is 0. So a is 3, b is minus 4, c is minus 7. So we get negative 21 here because it's a times c, and then negative 4. I'm thinking normally it's 3 and 7. Adjust that negative sign. So it's 3x squared minus 7x plus 3x minus 7 equals 0. Okay. And let's take a look. So we should factor out an x. That's all we can do. The 3 and the 7 have nothing in common. Okay. And then we will take out a 1 because I can't do anything else. And then those terms match. Okay. And then we use the zero product rule, which says that if you have two things multiplied, one of them has to be 0 because this is equal to 0. That's the whole point we set it equal to 0, by the way, is so we can abuse that fact that when two things multiplied equals 0, one of them has to be 0. So I just set the insides equal to 0, and then I solve them individually, so 7/3 or -1. Okay? So you'll be able to try 2 and 4 as part of your in-class practice, and if you don't finish that, that'll be for homework, and that goes for these even ones as well. These ones actually are a lot faster. You'll see that for this problem, A is 1, B is -5, and C is question mark? I mean, it's not even there. So that's a special case where C is 0. There is no like +7 or like a constant added there, like compared to this one, we had -7. This one doesn't have that. So when that happens, you still want to set equal to 0, but you can actually take out an X to start, right? We practiced doing stuff like that with the GCF. And then you actually get a one-way ticket then. You don't even have to factor. This is factored, right? You don't have to do anything else. So either X is 0 or X minus 5 is 0, because those are two things multiplied. So the final answer is just this. And you can plug them in for X and see that it's true. If you plug in 0, you get 0 minus 0. And if you plug in 5, you get 25 minus 25. Let's try that again. So you have to set it equal to 0 to start. That's the step for all of them. So you can at least see what you have. Okay. And I noticed that they both have an 8x actually. So I want to factor that out. So 2x minus 1. Because I divide each of these by 8x divided by 8x. So zero product rule says 8x equals 0 or 2x minus 1 equals 0. So x equals 0 or 2x equals 1, but that's really just x equals 1/2. Okay. And then so that's what you have to do when C is 0. Now sometimes, like in this problem, A is 2, C is -32, but B is 0, because there is no term like 7x in there. Remember, it's ax squared plus bx plus c. There is no middle term. B is 0. So that means we're not really, you could do a puzzle. It's a little awkward to do that. Remember from earlier though, all of these problems on the screen right now have, except for maybe the ones that, have a different square term, but like for 1 through 8, they all are missing the middle term. And we used the square root to help solve for those. So don't feel like you're locked in to factoring. This is all part of the same section in the book, and it's all called solve by factoring. So you can jump back to a different method if it's appropriate. And for this one, it would be. So yes, we have it solved for 0, and that's great, but we have no x, no linear term. So just start isolating for x squared, and then solve it by taking the square root, and then you're done. You don't have to factor. You could. And you would get like x plus 4, x minus 4, and then there's a 2 there. But this is way easier to just solve for x squared. For these other problems in this group, we can't solve for x squared because there's a pesky like x there. So 9 and 10 are special because they have b equal to 0, and 5, 6, 7, 8 are special because they have c equaling 0. And I've worked out some of those for you. Okay. So finally, the very last part. I know this has already been a long video, so I will be brief. Let's start by filling in the blanks. So the idea is we want to look at a graph and be able to write the equation. That's all we're really going to work on right here, and then identifying like some important parts. So no matter what form you're in, you always have A. Okay, we know A controls the stretch and compress, and it also controls flip if it's negative, right? That negative sign. So if A is positive, the parabola opens up, and if A is negative, the parabola opens down. Okay. That's because when it's negative, it has a negative sign, which means that it had flipped or reflected over the x-axis. So like it was like this, with the dotted line, that's the parent function, and then it does something like that. Well, that's a reflection over the x-axis. Okay. Now, in order to find A on this set of notes, we're going to check on the point next to the vertex, one away from the vertex, and see how far that point rises or falls from the vertex. For example, with this quadratic, the vertex is right here. Okay, the blue point. Okay. Now, let's look at this light blue point right here. I've already drawn for you. This goes over one block, and in this graph, one block is like one, distance of 1. So it goes over 1, and it goes up 2. So the A value is 2. On the other hand, for this one, if we look at this blue dot as the vertex and the light blue dot as the next point, it goes over one block, up one block. So A is going to equal 1 in that case. Normally A is 1 or negative 1. This one you can see it's not, because if you go over 1, we go down a quantity of 2 boxes. So A is negative 2. So it's just however many boxes you go up or down on the point next to the vertex. It's just a little trick that you can use. We could like solve for it with an equation and all that, but honestly, that's too much. We're not gonna do all that right now. We're trying to focus on the formulas. Okay. Standard form. We're familiar with standard form, right? C is the y-intercept. That's why we like standard form, because the y-intercept is readily available right at the end. The other forms don't have that. Okay. The axis of symmetry isn't too bad. Negative b over 2a. And if you want the vertex, it's that as the x value, and you got to plug that in to find y. So that's actually pretty stubborn. On the other hand, vertex form, super easy to find the vertex. It's just whatever h comma k is. So if it says x minus 5 squared, that means that h is 5. If it has like a plus 5 at the end or a plus 6, that means that k is 6. Okay, just remember that that negative sign is there in the form. Okay, the axis of symmetry is even easier in vertex form. It's just the value of h. Okay, and we like this form when we do transformations. Okay, the stretching and the shifting left and right, we always use a vertex form. So it's a very useful form. And then the formula that we've been working with today is factored form, because we've been factoring things and writing it in two sets of parentheses. Yeah. So in general, this would be factored form, would be A, and then x minus your first some value, and x minus a second value. Now, R1 stands for root number 1, and R2 stands for root number 2. But root is the same thing as just an x-intercept. Okay. Now, this factored form, of course, is really good for finding x-intercepts, which, remember, are the same thing as solutions. So when we're solving by factoring, factored form is essential. And we've already done this today. We've already been looking at quadratics. Set them equal to 0. So this is y, right? And then we've just been factoring. And then these, once you solve it, those are your solutions. All right. So with this example, this kind of gives you a glance of what I'm going to be asking you for, and then I'll do a couple with you. The vertex form, you just have to put in the vertex. And you also have to find A. Okay, so I noticed that the bottom point's the vertex, and it went left 2 and down 2. So I knew in my formula that h would be 2, or minus 2, and k would be 2, minus 2. So that's how I got that. And I got a was 2 for the reason we described earlier. And then for factored form, I just plugged in where the x-intercepts were, which were -3 and -1. So I plugged them into this formula. Okay. And then for standard form, I actually just did out the math and expanded or distributed the factored form, and then I got standard form. So that's where all those came to be. Okay. So let's just do a fresh problem. Well, we can look down here too quickly. These are just your basic vocab terms. So axis of symmetry, vertex, y-intercept, and solutions. You could even do that part first if you want, because that might give you a little bit of insight in the equation. So let's do that first for this one. So this is obviously my vertex. It's a minimum. Okay, so that's the point 2, -4. So that means my axis of symmetry is at that x value. So like this. Okay. The y-intercept for this problem is looks like it crosses. So this is y equals 1, 2, and 3 up to 5, and this is 0, -1. So it looks like it crosses actually at 0. Okay. And the solutions are where the dots are on the x-axis. So that would be here, the x-axis. These 2 points, where are they at on the x? That would be 0 and 4. Okay. All right. So the vertex form is going to look like y equals, and then x minus, and then I'm looking here. This is my h, this is my k. Always. That's what's so nice about vertex form. You don't have to even think about shifting. You can just steal it from there. So the formula is x minus h squared. So it's going to be minus 2 squared plus k. And then all we need to do is find out what a is, but that is just going to be over 1, up 1, 1. It's just this number right here. So 1, 2, negative 4. So all of these are going to be 1 as well. Okay. Let's take a look. So factored form. Factored form. So that would be the two factors, which you're supposed to write like this. So x minus one of your factors, or x-intercepts, and then x minus the other x-intercept. So we have 0 and 4. So it's going to be x minus 0 and x minus 4 with a right here. But you could even write that even more simply by just saying this. Okay. And standard form, just take factored form. And just expand it out. Distribute. Multiply. So this one's actually not bad at all. We just have to do that. So a is 1, b is minus 4, c is 0. 0 and 4. So these are your x-intercepts, right? And then this is your vertex. That's just what I want to get you to see. Okay. I'll let you try number 2. And then for number 3, you go over 1 and then down 2. So this is A. All right. Vertex form. So maybe it'll be helpful too if I wrote out vertex form so you can see me plugging it in. This is the last question, by the way. So -2. Now, this vertex is at 0, 2. So this is just simply 0, 2. Vertex is at 0, 2. So I can just put x squared, because h is 0, and then plus 2. All right. Now, where does this graph cross the x-axis? What are my roots? What are my zeros? What are my solutions? Those all mean the same thing. -1 and 1. So we would expect A, and then because the factored form is A, 1 x-intercept subtracted, and then the other one subtracted. Basically just in factored form. So one of them will make this a +1, and one of them will make it a -1. And that's factored. So it's whatever makes this 0, that is the root. So like for that first term, that would be -1, and then for this one it'd be 1. Okay, and then for so now we want to think, hey, do either of those look like they're already basically in standard form? Factor form never really will, but vertex form, yeah. This actually looks like that I can just carry that down. And that comes from the fact that h was 0, so there were no parentheses involved, so it already is in standard form. And that can happen, especially if the quadratic is on the y-axis like this one is. So we don't even need this space really. Now axis of symmetry, like I said, is the y-axis, or this. The y-intercept crosses at 2, which is up here. And the solutions are x equals -1 and 1, which show up here. Okay, and the vertex shows up here. All right, so the main point of these problems, again, there is a lot going on, but I just want you to kind of take a glance at all these formulas describing the same thing, and they're all equal to each other. You could prove that all these equations, if you expand them out, all of them expand out to this. Okay? So what's going to happen now is you're going to work on the evens for a bit, say 15 or 20 minutes, and then after that, you're going to get the part 2 worksheet, and the only part, you just have to do the evens of those as well. So again, you're going to get these guided notes, you're going to finish up the evens, and then you have to do the evens of another sheet that you will get called the part 2 of 11.4 worksheet, okay? So you have 2 things to work on, well, really 3, because Alex is always there. Today is the deadline for Alex, trying to get that 20% and all those topics in, 10 topics in. And here again are the 2 things for homework. Evens on this packet you have, and then evens on the worksheet that focuses only on factoring, the part 2. All right? Thank you, guys. I will see you next week. If you have any issues with any of the problems, just circle them and we can talk about them, all right? Thank you.